Welcome, everyone. Today, we will explore ratios, a fundamental idea in mathematics that helps us compare quantities. Imagine you have a room measuring 30 meters in length and 20 meters in breadth. The ratio compares these two lengths, length to breadth. We calculate it by dividing 30 by 20, which simplifies to 3 divided by 2, or 3 is to 2. Think of a ratio like a recipe. When making a cake, the amounts of flour and sugar may have a set ratio to keep the taste perfect. Ratios help us understand relationships, like how many boys there are compared to girls in a group, or the portion of an ingredient in a mixture. Equivalent ratios express the same relationship in different terms. For instance, 30 is to 20 and 3 is to 2 mean precisely the same relationship, just scaled differently. Now, think. Can you spot other situations around you where two quantities relate by a ratio? Maybe the number of pencils to erasers in your pencil box? Keep these examples in mind as we dive deeper. Let's look at some real-life examples to understand how ratios appear everywhere. For example, if 24 girls and 16 boys are going on a picnic, their ratio is 24 to 16. Simplifying this, just like before, we get 3 to 2. Imagine a table whose breadth and length are in the ratio 2 to 3. Or two friends, Sheena and Shabnam, own 2 and 3 marbles respectively. Their marble ratio is also 2 to 3. Ratios also help us when two people invest money in a business. If Ravi and Ronnie invest in the ratio 2 to 3, it means for every 5 parts of investment, Ravi puts 2 parts and Ronnie puts 3 parts. Understanding these ratios is important for fair sharing, like dividing profits or resources. Try to think of other examples around you where quantities relate by ratio. Maybe your family members' heights, or the number of trees and flowers in a park. Here is our first example, showing how to simplify ratios. Suppose we have a rectangular field with length 50 meters and breadth 15 meters. Our goal is to find the ratio of length to breadth in simplest form. Step 1. We express the ratio as 50 over 15, which is 50 divided by 15. Step 2. To simplify, we find the greatest common divisor, or GCD, of 50 and 15, which is 5. This means 5 divides both numbers exactly. Step 3. Dividing both 50 and 15 by 5, we get 10 and 3 respectively. So, the simplest ratio of length to breadth is 10 to 3, or 10 is to 3. Simplifying ratios helps us understand the true relationship between quantities without the clutter of large numbers. Try simplifying ratios you encounter in daily life, like recipes or sports scores. In this example, we face a common problem: expressing ratios when quantities have different units. We want to find the ratio of 90 centimeters to 1.5 meters. Step 1. To compare, we need the same units. Since centimeters and meters are units of length, let's convert 1.5 meters to centimeters. Since 1 meter equals 100 centimeters, 1.5 meters is 1.5 times 100, which equals 150 centimeters. Step 2. Now both measurements are in centimeters. 90 centimeters and 150 centimeters. So the ratio is 90 over 150. Step 3. Simplify 90 over 150 by dividing numerator and denominator by 30, their greatest common divisor. Dividing 90 divided by 30 is 3, and 150 divided by 30 is 5. Thus, the simplified ratio is 3 to 5, or 3 is to 5. Remember to convert units first before finding ratios. Otherwise, you might end up comparing apples to oranges. Let's analyze a workplace scenario where 45 people are working and 25 are females. Our tasks are: first, find the ratio of females to males. Second, find the ratio of males to females. Step 1. Calculate the number of males by subtracting females from total. 45 minus 25 equals 20 males. Step 2. Write the ratio females to males as 25 is to 20. Step 3. Simplify the ratio by dividing both numbers by their greatest common divisor, which is 5. Dividing 25 by 5 gives 5. Dividing 20 by 5 gives 4. So, the simplified ratio of females to males is 5 is to 4. In the next slide, we'll finish the problem by finding the ratio of males to females and discuss the differences. Continuing from where we left off, we found the ratio of females to males is 5 to 4. Step 4. Now let's write the ratio of males to females. That is 20 males to 25 females. Step 5. Simplify by dividing both terms by 5, the greatest common divisor. 20 divided by 5 gives 4, and 25 divided by 5 gives 5. Thus, the ratio of males to females is 4 to 5. Notice these two ratios, 5 to 4 and 4 to 5, are not the same. Ratio order matters because 5 to 4 means 5 parts to 4 parts, not the other way around. Ratios communicate direction in relationships, so pay close attention to how the quantities are placed. Let's understand equivalent ratios with this example. Find two equivalent ratios of 6 to 4. Step 1. Write 6 is to 4 as a fraction. 6 divided by 4. Step 2. Multiply numerator and denominator by 2. That is 6 times 2 equals 12, and 4 times 2 equals 8. Hence, 12 is to 8 is an equivalent ratio to 6 is to 4 because they express the same relationship scaled up. Step 3. Sometimes it's helpful to find simpler equivalent ratios. Let's try dividing numerator and denominator by 2. 6 divided by 2 is 3. And 4 divided by 2 is 2. So, another equivalent ratio is 3 is to 2. Equivalent ratios maintain the same proportion even when the terms scale up or down. You can find more by multiplying or dividing both parts by the same number. Try this with other ratios you come across to grasp the concept solidly. Let's work through filling missing numbers in the chain of equivalent ratios. 14 over 21 equals blank over 3 equals 6 over blank. Step 1. Start with the first equality. 14 over 21 equals something over 3. Notice 21 divided by 7 is 3. So, to keep the ratios equivalent, divide numerator 14 by the same number 7. This gives 14 divided by 7 equals 2. So, the missing numerator is 2. The ratio is therefore 2 over 3. Step 2. The second equality is 2/3 equals 6 over blank. To find the missing denominator, note that 6 is 3 times 2. That is numerator 2 times 3. Therefore, multiply denominator 3 by 3 to get 9. So, the missing denominator is 9. Hence, 14 over 21 equals 2 over 3 equals 6 over 9. All three expressions represent the same ratio. This exercise shows how to find missing parts of equivalent ratios by analyzing their relationships. We have learned how to work with ratios. Now let's see how to divide a total amount based on a ratio. Imagine you have some money to share between two people who invested different amounts into a business. The ratio is 2 to 3. First, add the parts of the ratio. 2 plus 3 equals 5 parts total. Each share is a fraction of the whole total, equal to that person's ratio part divided by 5. So, if the total profit is 5,000 rupees, for example, the person with 2 parts gets 2 out of 5 parts. That is, 2 divided by 5 of 5,000 rupees. Similarly, the person with 3 parts receives 3 divided by 5 of the total. This idea applies broadly, sharing money, resource allocation, or even distance traveled when split in ratios. Always remember, sum the ratio parts to understand how many equal shares the total is divided into. Then, multiply by each part. Let's apply our sharing rule to a profit-sharing example. Ravi and Rani invest money in the ratio 2 to 3. The total profit made is 4 lakh rupees, and it needs to be divided according to this ratio. Step 1. Add the parts of the ratio. 2 plus 3 equals 5 parts total. Step 2. Calculate Ravi's share. He receives 2 parts out of 5, so multiply 2 divided by 5 by rupees 4 lakh, which equals rupees 1,60,000. Step 3. Calculate Rani's share. She gets 3 parts out of 5, so 3 divided by 5 times rupees, 4 lakh equals rupees 2,40,000. So, Ravi receives 1,60,000 rupees, and Rani receives 2,40,000 rupees. This shows how using ratios allows fair division, proportionate to investment or contribution. Think about other contexts, like splitting a bill or dividing tasks, using the same approach. Here's a quick example. Divide rupees 60 between Kriti and Kiran in a 1:2 ratio. First, add the ratio parts. 1 plus 2 equals 3 parts total. Next, Kriti receives 1 part out of 3. So multiply 1 divided by 3 times rupees 60. That equals rupees 20. Kiran receives 2 parts out of 3. So multiply 2 divided by 3 times rupees 60. That equals 40 rupees. Thus, Kriti gets rupees 20, and Kiran gets 40 rupees. This simple example shows how dividing into ratio parts allocates the total fairly and clearly. Try using this method to divide candies or time slots with your friends. Now, it's your turn. Let's connect what we've learned to your daily life. Try finding the ratio of notebooks to books in your bag. Are there more notebooks or books? What is the ratio? Next, look at your classroom. What is the ratio of desks to chairs? Keep an eye out for any mismatches. Find the ratio of students older than 12 years and those younger in your class. What does that tell you about your classmates? How about doors and windows? Count them and write the ratio. Finally, draw any rectangle and calculate the ratio of its length to breadth. This will help you see geometry come alive. These practice questions help you spot ratios everywhere and understand their importance. Share your answers with friends and discuss.